Hello, I'm Marcelo and you are on arrivabene.com channel. In this video, we will try to demystify containers and Docker, making it easier to understand their benefits for software development. So, what is a container? According to the dictionary, it is an object that can be used to hold or transporting something. In cheap transportation, it is just a big metallic box to store goods. Since the 50s, ship transportation has been using containers. Today, more than 90% of non-bulk cargo is transported in containers. But why have containers revolutionized global transportation? Look at these two ships and compare how goods are organized. Can you imagine how hard is it to load or unload goods without containers? Using containers, loading, unloading, and storing goods is much more efficient. And what do containers have to do with IT? We also have to load, unload, transport, and store something. And this something is software. As virtual machines, containers are a kind of virtualization. Let's compare them with virtual machines. A virtual machine, or just VM, is an abstraction of a physical computer. It is like you have another computer on top of your computer. A container creates an isolated environment for running an application. Usually, a container has a single purpose. A VM has a whole operating system that might not be the same as the host. A container shares the host computer OS kernel, so the container must run with the same OS as the host. A VM is heavyweight and is slow to start. On the other hand, a container is lightweight and fast to start, perfect for escalating fast. A VM demands the physical resource to be allocated and reserved before running. A container also needs resources, but does not demand physical resources to be allocated and reserved in advance. Due to the number of resources necessary to run each VM, the maximum number of VMs per host might be small. As containers demand few resources, there might be many running in a single host. Despite VMs and containers being types of virtualization, they perform and have different purposes. Now, let's talk a little bit about the container's history. In the late 70s, the idea of process isolation was introduced by the Unix project, and it was adopted by the BSD project just a few years later in 1982. It might look too long, but remember, we didn't have internet then. Let's flash forward to the 2000s when FreeBSD introduced JOS, a small shared environment hosting provider. And then, lots of other projects and enhancements to this idea happened, until the Linux containers was implemented in 2008, which was the first complete implementation of containers in Linux. And in 2013, .Cloud Inc. released the open source Docker project. This success was enormous and they turned the company into Docker Inc. Since then, the containers adoptions have exploded. It is important to note that Docker Inc. is still contributing to the open source project. Docker is a client-server application, and the communication between the client and server is made through a REST API. The server is called Docker Engine. As a container, Docker does not run as a whole independent OS. Instead, it shares the kernel of the host OS. That means a container must run with the available kernel in the host. So, running a container designed for an OS not supported by the host is impossible. Let's take a look into the host's OS availability. Linux natively runs Linux containers, so the Linux kernel is supported. Windows OS supports Windows containers. Because it is possible to run the Linux kernel inside the Windows OS using the Windows Subsystem for Linux (WSL), Linux containers are also supported. macOS does not support containers, so the Docker engine runs a lightweight version of a Linux VM to support Linux containers, so the Linux kernel is supported. Now, let's analyze how Docker can help from a software development perspective. A development package contains much more than the developed code. It might contain libraries, dependencies, or even other software. Sometimes it might be tough to pack everything to deploy or share among the team. Who never heard the meme, "It works on my machine"? By packing everything in containers, we can abstract all this complexity to build the application environment to the container. Then we can send the container's image instead of the procedure to build the environment needed by the application. It might be to a server where it will be deployed, or escalated as required. Or to share among the team developers. To develop using Docker, we need the development computer to have the following: an OS with kernel compatible with Docker. The Docker engine is installed in the system. Please find the link to the official installation website in the description of this video. A Docker's images registries account, like Docker Hub, is necessary if you want to upload the image. A Docker image registry is a repository of Docker images like GitHub stands for source code. It is a central repository where we can distribute Docker images to developers or servers. Docker Hub is the official registry, but we also have others like AWS Elastic Container Registry, Azure Container Registry, and others. An essential aspect of Docker images is that they always will be built on top of an existing image, so the registry is necessary to start any image. You don't need an account on Docker Hub to use public images, but try to use only public images you trust. Using the ones with the label Docker Official Image is a good start. The process of packing, deploying, and running applications using Docker containers is called Dockerizing. To Dockerize an application, we must add a Docker configuration file called Dockerfile to the root folder. Dockerfile contains the receipt to the Docker engine creates the image. It contains the base OS, runtime environment, application files, prerequisites like third-party libraries, and environment variables. This is an example of a Docker file for a Python application. Let's break down and analyze each instruction in the file. From, it defines the base image, in this case the official Python 3. This image includes the OS Linux and the runtime environment Python. Label. It tags the new image with the description. Workdir sets the folder inside the image where all the following instructions will run on. If the folder doesn't exist, it will be created. Copy copies files or folders from the host to the image. Here, it copies the requirements.txt file to the image. Run runs a command on top of the current image and commits it, creating a new image as output that will be the base for the following steps. Here it runs the pip command to install all the dependencies on the requirements.txt file. Copy the entire content in the host's actual folder, the application source code, to the actual folder in the image, the folder defining the workdir instruction. All the files or folders declared in the docker ignore file, which is similar to a git ignore file, will not be copied. CMD defines what will be executed on containers startup. In this case, the command python with the argument .the/entry_point.py. The Dockerized application can be either packed in an image and uploaded to the registry or built by the Docker engine during the deployment time. All the server needs to run a Docker container is Docker engine running, access to the registry where the image is hosted. The server will download and run it inside the infrastructure following the Dockerfile instructions. You might be asking, why I have to learn Docker? More and more companies are adopting containers to improve the development process or to escalate their applications, such as Spotify, Udemy, Shopify, and Pinterest, just to cite some examples. The most significant cloud providers have services that allow the use of Docker in their infrastructure. Using containers, we no longer need to maintain massive documentation on building the application's execution environment. We guarantee the application will run in the same environment on every machine. Even if Docker is not the chosen container technology in the project you are working on, it still is an excellent option to start learning about containerization. I hope you enjoyed this video. Thanks for watching.